Good evening, and welcome to the first of three videos regarding Chapter 8 in your textbook, which is all about what we call linear regression. Now, um, we learned in Chapter 7 that we could calculate what's called a correlation coefficient. And this is simply the relationship between two variables, an x variable and a y variable that we find on a graph. The linear regression is a measure essentially of the average of that correlation coefficient. If the correlation coefficient is perfect, in other words, either 1 or -1, then the linear regression line is also perfect because every point, every data point will fall right on that line. However, in reality, that very seldom happens. A correlation coefficient is very rarely a perfect 1 or -1. And so, what we're going to do this time is look at a scatter plot, not one that is perfect with every dot on a specific line, but rather scattered a wee bit at least all over the graph. And so, one of the goals for Chapter 8 is to look at how a regression line summarizes a scatter plot. All right, the scatter plot itself can be uh, kind of all over the place, but as long as there's a trend, we can plot a regression line. Now, any line, as you learned in algebra, has an equation that's associated with it, right? If you recall from high school mathematics, we use the line y equals mx plus b. Remember that one? All right, y is obviously the y data, the y-axis point. M was the slope, x was the x-axis data point, and b was the y-intercept. And so what we do here is we plot that line. We're then going to continue that and talk about the variation that's involved with each value of x and the values of y that are associated with it. And that's called the standard error of the estimate. We'll continue and talk about the strength of a relationship. In other words, how spread out are the y values for each value of x, because that will help to determine our accuracy in predicting the y scores. And finally, we'll talk about what the proportion of variance accounted for is, what it tells us, and finally, how to compute it. All right. So those are the things that we're going to be talking about here in Chapter 8, just as a brief little summary for you. Okay. Let's start with the definition of a linear regression. A linear regression is a statistical procedure that uses relationships to predict unknown y scores based on the x scores from a correlated variable. So essentially what we're going to do here is we're going to take an xy axis, and we're going to have a bunch of data, and notice that they're all in line. So these are the various y values for certain values of x. All right, and so there's my scatter plot here. Now, in this particular case, I would say that the best fit line, or in this case, the regression line, is going to look something like this. Now, there's no numbers involved here, so this is obviously not a perfect drawing, but that's what it is. And so what the blue line represents is the average value of y at this value of x, and the average value of y at this value of x, and the average value of y at this value of x, and so on. And so this can actually tell us a number of things about the relationship between the x-axis and the y-axis. Now, this line, of course, the slope of this line is going to be very important because it will tell us just how strong the relationship is here. If you've got a relationship where your data looks like this, whoops, that was pretend that's a straight line, and all the data is right on the line, well, that's a very strong relationship here. On the other hand, if you've got a set of data and you end up with a line that looks something like this, that indicates a very weak relationship here between the x and the y data. Now, this is very similar to what we said about the correlation coefficient, the value of r. All right, so these things are definitely related to one another. So keep that in mind as we go through and a little bit further into this our explanations of what a linear regression actually is. Okay. So the line itself is the straight line that summarizes the linear relationship in a scatter plot by, on average, passing through the center of y-scores at each x. Now, that doesn't mean it passes through exactly the center of the y-scores for every x, but on average for all of the values of x. All right, and so it's the average line. All right, it's a straight line that summarizes this linear relationship by in a scatter plot by on average. That's the key term here. All right, so keep that this term right here in mind. All right. Yeah. So, on average, passing through the center of the y-scores at each x. All right. So let's keep that in mind as we move a little bit further through all of this this gobbledygook. All right. So the symbol y prime stands for a predicted y-score. All right. And so this is essentially the average y-score at a given value of x, essentially, all right, where it would fall on that linear regression line. And so each y prime value is our best prediction of the y-scores at a corresponding value of x. And this is, of course, based on the linear relationship, the y equals mx plus b bit. Now we're going to change that formula, that y equals mx plus b, just a wee bit, but essentially y prime is going to equal mx plus b. Remember that from, I don't know, ninth grade algebra maybe even earlier. I'm not absolutely 100% certain. Now, unfortunately, your textbook uses a slightly different version of this formula. And so what they do is they say that y prime is going to equal bx plus a. Now, I personally hate this because it does lead it to some confusion because the b's have kind of swapped places here. But for our purposes, for the remainder of this chapter and the discussion of this chapter, b is going to represent the slope, not m, b, okay? And a is going to represent the y-intercept value. In other words, the position, the y-score when x is equal to 0. All right. And so keep that in mind as we go through. Now, this y prime score may not actually ever appear in your data set. All right. It's the average, it's a predicted score based on the regression line, but it may not actually be the value of y that you get for x when you collect your data. All right. So that leads us, or that brings us to the equation that I gave you just a moment ago on the previous slide. All right, this is the linear regression equation. All right, so y prime equals b times x plus a. All right, it summarizes the linear relationship and produces the value of y prime at any value of x. All right, so this is the predicted y. This b is the slope of the regression line. X is the x.
It's 7 o'clock.
Thank you, Jesus. This is the x value at whatever you happen to be looking at, and y, or I'm sorry, a is the y-intercept. And of course, the y-intercept occurs when x equals 0. All right, so it's the y prime value when x equals 0. And if you think about it, that makes sense because 0 times b is 0, right? And so y prime would simply equal a, all right? So that's where these terms come from, all right? So y prime equals b times x plus a. Okay. Now, the slope b indicates how slanted the regression line is. In other words, the larger the value of b, the steeper the slope is, right? Very high or close to 0 is almost horizontal, all right? And so that value of b indicates how slanted the regression line is. And remember, this can be both positive and negative. And so the value of b also indicates the direction in which it slants. If it's going up like this, then it's a positive slope. And if it's going down like this, it's negative slope. All right, so this is positive, this is negative. All right. And of course, you should remember that from previous math lessons. Now, the y-intercept, a, is the value of y where the regression line crosses the x-axis. In other words, when x equals 0. And so if you've got a regression line that looks like this, all right, and this is the x-axis, here x equals 0, this value right here is the point 0 comma a. All right, that's the value of y when x equals 0. All right, the y-intercept. All right, and again, all of this stuff about the slope and the slope formula and the y-intercept and all of this should be familiar to you from your days of high school math. All right, y equals mx plus b, only now we're saying y prime equals bx plus a. All right, but same basic concepts. The math is the same. The mathematical rules are the same. All right, so just keep that in mind. Okay, so here are 4 examples of regression lines with different slopes and obviously different y-intercepts, okay? If you look at line A, you'll notice that this is, excuse me, a perfectly horizontal line. So the slope there, the value of b, little b, is 0, all right? And the y-intercept is 8. And so in this case, it would be the formula would be y prime equals 0, all right, times x plus 8, all right, or simply y prime equals 8. Okay, no relationship. It doesn't matter what the x score is, the y score is 8. Now for b, you've got a slightly different relationship here. All right, here the slope a is positive. Okay, I don't know exactly what it is. Let's see. We got 2 is 3 and 3, 4. I'm not really sure, but a is obviously a positive slope, and it looks to me like the y-intercept b is going to equal 2. Okay, because it looks like if it continues, it's going to pass right through the 2 there. All right. For c, the slope is also positive. All right, but it's a higher positive. It's a greater number. So if the slope over here was, let's say, 1/2, the slope over here might be 1. All right, it's a greater slope, and the y-intercept, God only knows, but it's going to go down here. It's probably maybe -2, something like that. All right, we don't have any actual data points here. All right, I'll put a big fat question mark there. Now for D, the slope is obviously a negative number, all right, because now we're going downhill, all right, and the y-intercept, the value of B, looks to be 9, all right, yeah, I suppose about 9, all right, approximately, all right, and so lines B and C imply positive relationships, line D implies a negative relationship. And of course, I'm guessing at the values of the y-intercept for each of these relationships, but hopefully you get the idea. of this. All right. Okay. Now, this is a very ugly looking formula, but I don't want you to get too worried about it. Don't get all tensed up about it. All right. The formula for the slope b is this: b equals n, which is the number of data points, times the sum of x times y, the product of x and y, minus the sum of x times the sum of y, all over n times the sum of x squared minus the sum of x squared. All right. Now, you may think, oh my God, how am I going to keep track of all that kind of stuff? Blah, blah, blah. Remember how we did it when we were calculating the correlation coefficients, right? Make yourself a table. Calculate the sum of x and the sum of x squared and the sum of x times y and all of the things that you need to do. All right. And so, but since we usually calculate the value of r first, all right, we probably already have all of the elements of this formula. All right. So if you've made a table with all of your data points and you've calculated all of these other things, you probably already have them. And so you don't need to worry too much about recalculating or additional calculations here. Okay. Now, the next couple of slides just go through rearranging the formula to calculate the values that we have. All right. So, for example, if we take y equals bx plus a, and we rearrange it algebraically to calculate the value of the y-intercept, oh, come on now, we'll start with this. The average value of y is going to equal b times x plus a. Now, if I want to get a all by itself, what do? I subtract bx from both sides. All right, and what does that leave me with? It leaves me with the average y minus b times the value of x, the average value of x, I should say, here, right? And that's going to equal a, which is essentially what I've got right there, right? It's the same formula, just I've switched the locations of a and y minus bx, all right? So that's how you would calculate the value of the y-intercept, assuming that you know the average value of y, the slope of the regression line, and the average value of x. Oops. Okay. Now, so to find y prime for a given x score, you simply multiply the slope, b, times the score, and then add the y-intercept value, which is a, right? And this is, again, the same thing that you did, come on now, that you did in your high school math classes, right? Y, ugh, that's ugly. Y equals mx plus b. It's the same format, right? Y equals slope times x plus the y-intercept. All right, y equals mx plus b. Now we're just writing it as y prime equals bx plus a. Okay. All right. So here's the summary of how to calculate the linear regression equation. All right, the first thing you got to do is calculate the correlation coefficient that we did in chapter 7. Okay. Then you can compute the slope, where the slope equals n times the sum of x, the product of x and y, minus the product of the sum of x and the sum of y, all over n times the sum of x squared minus the sum of x quantity squared. Once we've got the slope, we can then calculate the value of the y-intercept, a, where a equals the average value of y minus b times the average value of x. Substitute in the values of a and b into the formula for the regression equation. Y prime equals b times x plus a, and then plot the regression line on a graph. All right, and once we've done that, we can then compute the predicted y prime score for any value of x. So, oh yeah, all right, x equals 6. Oh, y prime equals b times 6 plus a. All right, or, x equals 12. All right, y prime for 12 equals the slope times 12 plus the y-intercept. All right, it's a fairly straightforward equation. It does involve a good deal of work. All right, by hand, you got to make a chart and you got to calculate the sums of all of these crazy things. Right, the sum of the product of x and y, the sum of x, the sum of y, the sum of x squared, and the sum of x quantity squared. All right, in order to do this. But once you've done that, and you probably have most of those terms already in calculating the value of r, you now can use this to compute the predicted value of y prime for any value of x. Okay, so that, my friends, is actually where we're going to leave it for this first of 3 videos on chapter 8, and I hope you learned something.